Prove root 2 is irrational. So this is an application of whatever we just studied now. So let's start off with using proof by contradiction. Okay, so here we're talking about, let's assume root 2 to be, what is contradictory of irrational number? That root 2 is a rational number, right? That is, root 2 is in the form of p by q, where q is not equal to 0 and p comma q are co-prime. This is very important. Okay, so this point is not to be missed. The next very step is squaring both sides. So we have root 2 the whole square is equal to p square by q square. If I rearrange this, I'll get 2 is equal to p square by q square, is it not? Then we have this, or I can write it as p square is equal to 2 into q square. So p square is made up of, it's a product of 2 into q square. What can I do with this? Well, 144 is made up of 2 into 72, right? So 144 is made up of 2 and 72, that is, it's a product of 2 and 72. So we can conclude that 144 is divisible by 2 and 144 is divisible by 72. We can take some weird number. Let us take some. Okay, that's too much. Right? Into 45. Okay, this particular number. Right? This particular number is a product of 45 into whatever I typed. Now, can I tell that this entire number is divisible by 45? Right? So this answer, if I divide with 45, I'll get a whole number. Is it not? Because it's a product of 45 and something, it has to be divisible by 45. Right? This number is a product of 45 and something, so it has to be divisible by 45. So with the same logic, p square is a product of 2 and q square. So p square is divisible by what? 2. Is it not? So 1 minute. Now p square is divisible by 2. Can I, with the help of the first law which we saw, a square if it's divisible by p and a is divisible by p. If a square is divisible by p, a will be divisible by p. In the same way, p square is divisible by 2. This implies p is divisible by 2. Right? So now, since it's divisible by 2, can I write p as 2 into some number? Is it not? Again, I'll give an example and explain it to you guys. So we tell that 10 is a product of 2. 10 is product divisible by 2. 10 can get divided by 2 to get a whole number. So can I tell that 10 is a product of 2 into 5? And this is something for us as of now. We don't care about that. And 130 is a product of, it's divisible by 10. So can I write this as 10 into something? I can, right? So if P is divisible by 2, P will be a product of 2 into some what? Some where, just a minute, where n is a positive integer, is it not? So n has to be a positive integer. Okay, so I mean it's a bit weird, this last, not this, I mean second half, this part is a bit weird, but this is the confusing part for many. So you can go back and watch it again, right? It's with example you understand it. Don't try to memorize it. With example, make a sense out of it. Then you can, if you want to memorize, then you can memorize, but understand it with examples. Okay, so now I will call this where is it? Yeah, this as equation 1. So in the next step, I'm going to substitute in 1. So in place of P, I'm going to write 2 in the whole square is equal to 2 into Q square. Okay, so we have 2 in the whole square is 4 into n square is equal to 2 into Q square. So we'll divide with 2 both the sides and we'll get 2n square is equal to Q square, right? Or Q square is equal to 2n square. So now looking at the pattern over here, whatever we did over here, it's a similar pattern. So how can we go about? Since Q square is a product of 2 and n square, Q square is divisible by 2. Thus Q is divisible by 2. Okay, so what did we do? We started with the proof by contradiction statement, and we wrote the contradictory part, and then we squared it, and then we simplified it a bit, and then I substituted that, okay, P is a product of 2 into something, so I substituted that, and then I simplified, and I ended up with P being divisible by 2 and Q being divisible by 2. So from equation 2 and 3, right, I can conclude that, therefore from what can I conclude? 2 and 3, we can conclude that P comma Q have 2 as their factor. Is it not? 2 is going to divide P and Q as per this 2 information. But the one which I made you mark, this part, tells that P and Q have to be co-prime. That is, the HCF between them should be 1. But here we are getting 2 as a factor. So with this 2 contradicts each other. So you can tell, but this contradicts P and Q being co-prime. And this contradiction is because of this contradiction is because of our wrong assumption. Therefore, root 2 is irrational. Okay, that's how proof by contradiction works. It's a whole lot of writing, a bit of tough math as well. So I'm sure quite a few will find it tough, but it's okay. One good thing is you have any number over here, root 5, root 10, root 11, the proof remains the same. Okay, there's no variation. The proof remains the same, just that it is, instead of root 2, it's root 5 or root 11. That's it. Okay, it's quite simple, and this is the only kind of question you'll get. Proof wala. So other proof, actually there are few more proof, but it's not as tough as this, but everyone finds this tough. So just go through the syllabus. End of it, you'll see that it's the same pattern again and again, and we always start with, there are only few steps. First step being use proof by contradiction. Second step is square both the sides. Third step is substitution, and the fourth step is conclusion. If you remember these 4 steps, you are done.